Last class was polygon law of vector addition. Okay, so polygon law of vector addition. So what we have is, suppose if there are more than two vectors, suppose you are having one vector over here plus say another vector will be like this, and one more vector maybe in this direction. Okay, so if this is the case, so what we are going to use, we are going to use the polygon law of vectors. Okay, so if this is the vector A and vector B and vector C. Okay, so resultant, so how we can get the resultant? Take vector A over here, then vector B over here, then vector C over here. So what will be the resultant? Resultant will be from tail of first vector to the head of last vector. Okay, so these all are in same direction, these all are in same direction, but your resultant will be what? It will be in opposite direction, so from tail to the head. Okay, so this is what the resultant vector, that is vector A plus vector B plus vector C. Okay, so what will happen if I change the order? If I take C first, if I take the C first, okay, so this is what the vector C, then vector B I will take over here, this is what vector B, then vector A, so vector A is going to be here. Okay, so now again resultant is what? From tail to the, all are in this direction, so resultant should be in what? Opposite direction, so from tail to the head, so from tail to the head. Okay, so this is what going to be your resultant. Resultant R equals to vector C plus vector B plus vector A. So look at the vectors. Resultant, here it is in upward direction, so this is what the resultant. Here also it is in upward direction, so this is the resultant. Okay, so magnitude is going to be same only, no need to worry about that one. So by changing the order, resultant is not altering. Okay, so no need to worry about the order, whichever order you can take. Okay, or suppose if you have the number of vectors, say one vector is in this direction plus another vector is in this direction, third vector will be in this direction, fourth will be in this direction, but sixth will be in this direction, and seventh one will be in this direction. Okay, suppose if this is the case, so what will happen, we'll see. So it is starting from here, so first vector I will take over here, so this is what your first vector. So second vector, so tail should coincide with what? Head of the first vector, so tail should coincide with the head of first vector. Then one more is there in this direction, tail should coincide with head, so tail should coincide with head. So then fourth vector, tail coincide with head, so this is what the tail and head. So next it is in downward direction, this is what the downward direction. So one more is there, so that is coming to here. Okay, now question arises, what will be the resultant vector? It has started from here, say vector A plus vector B plus vector C plus vector D and vector E and vector F. So resultant is equals to vector A plus vector B plus vector C plus vector D plus vector E plus vector F. Okay, so what will be the resultant then? It has started from here and again it is coming back to the same position. So what is the resultant? Resultant should be should start from what? Tail of first vector to the head of last vector. Tail of first vector is here only, and where is head of last vector? This is what last vector, so head of last vector is also here only. Then what is the distance between the tail of first vector and head of last vector? There is no distance, means it is 0. So resultant here it is what? It is going to be a 0, because there is no displacement between head of last vector to the tail of first vector. Okay, so that is why. So resultant is going to be 0. Resultant is going to be 0 means what? Resultant is going to be a null vector. So we can call it as just null vector. Okay, so sometimes your answer may become the null vector. So no need to worry about that one. So we have to just follow what is going on. So don't think that when you are getting the 0, maybe order is no. Whatever order you can take, you can change many orders here. Again, your answer will become what? Answer will become the null vectors only. Okay, so answer is going to be a null vector. This is what resultant of those 6 vectors. Okay, so like this we can take help of polygon law or triangle law. So we'll take one more example, so then we'll arrive for the next property. Okay, so suppose if I take look at the magnitude of my vectors also. This is what vector A, and plus I will take one more vector, that is it should be in this way. Okay, so this is what vector B. So I want the resultant. So resultant, what you can simply use the triangle law. So what will be the resultant? So resultant will be, so length is all this much. Okay, so this is what your vector A. Okay, so this is what your vector A. So vector B over here in this way. So this is what your vector B. So resultant will be in opposite direction from tail to the head. This is what vector B, from tail to the head. This is what? So this is going to be what? A plus B. Vector A plus vector B. Now what I will do? I will multiply some scalar quantity, or I will multiply some number to this A and B. What I will do? I will multiply 2 to A and B. Okay. So multiply vector A and B. Multiply vector A and B by 2. So if I multiply A and B by 2, what will happen? It's 2 is what? 2 is a number, it's a scalar quantity. So simply you can use your normal algebra. So it will become what? 2A. So A will become what? 2A and B will become 2B. Okay, so 2A means its length will become 2 times the initial one. So this will become this much. Okay, so some less or more. So this is what vector A plus, what about vector B? Vector B is going to be this much. Okay, so this is going to be vector B. We can say 2A and 2B. Okay, so this was A, this became 2B, 2A, B became 2B. So that is why I am changing the length also. Okay, now add 2A and 2B. We'll see what we will get, whether we will get the again same A plus B or something else. So so 2A, I will take this vector over here. This vector I will take over here. So this is what your 2E. This is what you are 2B. Okay. So from here to here. So what about 2B? 2B is going to be here. In this way. So this is what you are 2B. Okay. So this is what you are 2B. Okay. So this is 2A and this is 2B. Okay. So maybe I have taken a little longer one, I think. 2 times B, this one. Okay. Okay. This is what 2A and that's what 2B. Okay. Now what will be the resultant? Resultant will be from here to there. Okay. 2A to 2B. So resultant will be this one. Better if we use the proper scales and everything. Okay. So this is what going to be resultant. Direction is in this way only. Direction is in this way only. So this is what 2A plus 2B. 2A plus 2B. See here. This 2A plus 2B is having the same direction. So is it not looking like 2 times A plus B? Is it, this vector is equal to what? 2 times A plus B. So A plus B is this much. So it is going to be 2 times A plus B. Okay. So can I write it as 2 times vector A plus vector B? So I can write 2A plus 2B as 2 into A plus B because it is exactly 2 times this one. Okay. So this resultant is 2 times this one. So can I write this I will take it as a R2 and this I will take it as a R1. Okay. So can I write it as vector R2 is equals to 2 times vector R1. So vector R2 is equals to 2 times vector R1 because magnitude is 2 times, so direction is same. So what is R2? R2 is 2A plus 2B equals to 2 times. What is R1? Vector R1 is nothing but vector A plus vector B. So vector A plus vector B. Okay. So can I write something? 2 times vector A plus B is equals to what I can write? I can write it as 2 times vector A plus 2 times vector B. Okay. So this is what I wanted. This is what the next property of vector addition. So this n is what? N is a scalar. So sorry, 2 is a scalar. So I can take in place of in general. So in general, I will take this as n. So what I can write? N into vector A plus vector B is equals to n times vector A plus n times vector B. What is this? Again, you must have gone through this one in your high school. So this is nothing but what? Distributive law. Okay. So this is nothing but your distributive law. So this is what the next property. So what is the next property? So distributive law holds. So distributive law holds for what? For vector addition. Distributive law holds for vector addition. So this is what third property. This is what the third property. First property was what? Commutative law holds. Second property was associative law holds. So third property is distributive law holds for the what? Holds for the vector addition. So this is what we wanted to arrive at the property, that is distributive law. Okay. So distributive law holds for vector addition. Okay. So again, this will come under what? This will also come under properties. Okay. So what you have to do? You can tell the what statement, that is distributive law holds for the vector addition. Then write this statement. Then you can take two vectors. Then the multiplication of that vector you can take. So you can show that. So vector resultant of 2A plus 2B is 2 times B, A plus B. So that will prove the distributive. So next, sometimes situations comes like your vector addition is not possible to apply over there. Triangle of vector addition. Okay. So in that case, what we can do? What triangle of vector addition suggests? So head tail should coincide with head. So again, tail should coincide with head. So head tail it is like that. So instead of that one, if vectors are like this, if vectors are joining tail of one vector joining with the tail of another vector, in that case your triangle is not possible. You cannot apply the triangle now. Okay. So what are the situations like that? Suppose there is some luggage or something, or some heavy object is there. Okay. So what will happen? One person is pulling it from this side. Okay. Another is pulling it from this side. So two people are handling this one. Okay. So two people are handling. So what will happen? What is their main intention? So they have to bring this object in forward direction. So where it will come? So this will come in this direction. So object will come in this direction. Okay. So if you take this as vector B and this as vector, this as vector A and this as vector B. So resultant will be in this direction. It never be either in this or this. It will come in forward direction. So this is what going to be a resultant. To find this resultant, it's not possible to apply your triangle of vector addition, because head is not joining with the tail of another vector. Both the tails are joining at a point. Okay. So in this case, your triangle lie is not possible. Then what will be the what will be the what is the how we can solve, or what are the next laws we can apply over here. Okay. So if this is the situation, so if I take these two vectors separately, so when one vector is in this direction and another vector is in this direction. Okay. So here this is the situation. Okay. So these two vectors only I will take for example. So one vector I will take in this direction and another vector I will take in this direction. So this is our vector A and this is what vector B. So if this is the situation, what will be the solution? Now, very simple. You have to join what? You have to join tail to tail. Okay. So because situation is like this. So tail of one vector. Say I will take vector A over here. So this is what the vector A. So another vector B is going to be. Okay. So this is what vector B. B and A. B and A. Okay. So both tails are joining. Obviously triangle is not possible. So if this is the situation, we have to go for another law called as parallelogram law of vector addition. Okay. So what it suggests? Draw two vectors such that their tails should coincide at a point. Now what you have to do? First step is draw the given two vectors such that their tails should coincide each other. Okay. So next step is you have to complete the parallelogram. So is it if you take these two as the sides of parallelogram, so just to complete it, so what will happen? So just you can draw parallel line, means parallel to B. So this is what going to parallel to B. Okay. So similarly draw parallel to A also. Okay. So this is what parallel to A. So now this became what? Now this became a parallelogram. Okay. Now this became what? This became a parallelogram. Okay. So now after completing the parallelogram, what will be the resultant? Very simple. The diagonal of parallelogram which passing through the point of intersection of A and B will be your resultant. What is the point of intersection of A and B? This is what point of intersection of A and B. So the diagonal of this parallelogram which passing through the point of intersection. So diagonal is what? This is what going to be your diagonal. This is what going to be your diagonal. Okay. So this is going to give you the resultant. Resultant is what? Vector A plus vector B. Okay. So this is what we call it as the parallelogram law of vector addition. So what is the first step? So draw vector A and B. Draw vector A and B such that their tails should coincide at a point. Okay. So you are drawing vector A and B such that their tails should coincide at a point. So what is the second step? Now complete the parallelogram. Okay. Now complete the parallelogram. Now complete the parallelogram. Okay. Now complete the parallelogram. So I have completed the parallelogram. So what is the resultant? Now resultant is, so the diagonal passing through the diagonal of, better to mention, of parallelogram, passing through, because one more diagonal will come here. So that diagonal will not be our resultant. Only this diagonal which is passing through the point of intersection point of intersection of A and B, point of intersection of vector A and B gives what? Gives resultant. Okay. So first step is draw a given A and B such that their tail should coincide at a point. Second step, complete the parallelogram. Third step, the diagonal of this parallelogram, which is passing through the point of intersection of A and B, will give you what? Will give you the resultant. Okay, it's very simple. So how we can define this? So can we define this one? So how we can define? If any two non-zero vectors represented as the two adjacent sides of a parallelogram, then diagonal of the parallelogram which passes through the point of intersection of two vectors will give you what? Will give you the resultant. Okay. So what I can write, if two non-zero vectors are represented as two adjacent sides of parallelogram, then the diagonal passing through point of intersection of those two vectors gives the or represents the resultant. Then the diagonal passing through point of intersection of two vectors represents the resultant. Okay, so resultant. So this is what the definition or statement of what we can say parallelogram law of vector addition. So this is the heading is parallelogram law of vector addition. So parallelogram law of vector addition. So what is the statement? If any two non-zero vectors represent as the two adjacent sides of parallelogram, then diagonal passing through point of intersection of those two vectors will give you what? Will give you the resultant. So this is what the statement. Okay. So you have to write the statement. Then you can take two vectors, draw those two vectors such that their tails should coincide, then complete the parallelogram. So after completing the parallelogram, so diagonal you are drawing, you will get the two diagonals, one is in this direction, another is in this direction, but they are clearly mentioning the diagonal which passes through the point of intersection of A and B or two vectors give you the what? Give you the resultant. So okay, so this is again one more very important law as your board exam is concerned. Okay, so most of time they will ask you to state and explain the parallelogram law